The discovery of AA is related with the disease of scurvy. Scurvy was a common disease in the world's navies and sailors until the beginning of the 19th century, with serious symptoms such as bleeding of mucous membranes, anemia that lead to eventual death. Let us consider first the history and the discovery of L-ascorbic acid. Humankind has long suffered from a lack of understanding of basic nutrition. Scurvy was among many diseases suffered due to malnutrition. It wasn't until the 1930s that Albert St. Georgi discovered the chemical ascorbic acid, vitamin C, that enables the body to efficiently use carbohydrates, fats and protein. His discovery was among the foundations of modern nutrition. Those sitting down to nutritious meals usually do not consider what would happen if fresh vegetables and fruit or vitamin supplemented juices and cereals were not routinely available. Centuries ago, sailors experienced such a lack firsthand, swollen and bleeding gums, loose teeth, hemorrhaging under the skin and slowed healing of wounds. What we know now as vitamin C was in short supply on most ships, and human bodies reacted by developing the condition known as scurvy. Death could and often did quickly follow thousands of miles away from otherwise life-sustaining provisions.
Scurvy had long been the curse of those who sailed for extended distance without fresh food and supplies, with the first clear-cut description of the malady appearing in the medieval records of the European cultures. Towards the end of the 15th century, scurvy was cited as the major cause of disability and mortality among sailors on the long sea voyages. According to Jonathan Land, in 1499, Vasco da Gama lost 116 of his crew of 170. In 1520, Magellan lost 208 out of 230, all mainly to scurvy. Later, the Portuguese planted citrus fruit trees and vegetables in St. Helena, a stopping point for homebound voyages from Asia, which sustained Persian siege. At the same time, Danish mariners were long acquainted with the condition and included lemons and oranges in their marine stores. However, it was not until 1753 that scurvy was recognized in the British medical community at large as directly related to dietary deficiency. The first attempt to give scientific basis for the cause of this disease was by a ship's surgeon in the Royal Navy, James Lind. While at sea in May 1747, Lind provided some crew members with 2 oranges and 1 lemon per day, in addition to normal rations, while others continued on cider, vinegar, sulfuric acid or seawater, along with their normal rations in one of the world's first controlled experiments. The result shows how that citrus fruits prevent the disease. Lind published his work in 1753 in his treatise on the scurvy.
In 1769, William Stark, a young British physician, began a series of experiments on diet and nutrition, using himself as the experimental subject. After consuming only bread and water for 31 days, Stark added other foods to his diet one by one, including olive oil, figs, goose meat, and milk. In 2 months, Stark recorded that his gums were red and swollen, bleeding easily to the touch. 7 months later, he died, possibly from scurvy and likely from the cumulative effects of malnutrition. Stark's diet was heavy on meat and starch, but devoid of fresh vegetables and citrus fruits. As mentioned earlier, 16 years before Stark's ill-fated experiments, Scottish physician James Lind, having observed the preventive and curative powers of citrus fruits and lemon juice during his years as a naval surgeon, wrote a treatise recommending their mandatory consumption by British sailors. By 1795, Lind's advocacy had resulted in the issuance of lime juice to all naval vessels and the gradual elimination of scurvy within the entire British fleet. At the time, no one, including Lind, knew of the existence of ascorbic acid, which would eventually become commonly known as vitamin C.
It would take more years to pinpoint the scurvy prevention substance responsible for maintaining the body's connective tissues. That would take the miraculous work of a brilliant Hungarian-born researcher named Albert Szent-Györgyi, whose isolation and identification of vitamin C and discovery of the metabolic mechanism that enables its use within cells would be recognized with a Nobel Prize in Physiology or Medicine. In 1928, Albert Szent-Györgyi began his scientific career by studying the chemical changes that occur when cells utilize foodstuffs, such as carbohydrates, fats, and protein, a process sometimes known as biological combustion. In the course of his studies, Szent-Györgyi isolated a molecule from adrenal glands that lost and regained hydrogen atoms. This hydrogen carrier containing 6 carbon atoms had the property of a sugar and acid. Szent-Györgyi christened it hexafluoric acid.
In 1930, Szent-Györgyi returned to Hungary, accepting the post as the professor of medicinal chemistry at the University of Szeged. There he showed his sample of hexuronic acid to J. L. Svirbli, an American-born chemist of Hungarian descent, who had previously worked with Charles King, a vitamin researcher at the University of Pittsburgh, with the suggestion that it might be the anti-scorbutic factor. In this context, it may be mentioned that the name anti-scorbutic was used in the 18th and 19th centuries for foods known to prevent scurvy. Svirbli, working with Szent-Györgyi, conducted a landmark experiment on guinea pigs, which, like humans, must ingest hexuronic acid to maintain health, since it cannot be produced within their bodies. Svirbli divided the animals into 2 groups, one that received boiled food, boiling destroys hexuronic acid, and the other that was fed food enriched with hexuronic acid. The latter group flourished, while the first aggregation of guinea pigs developed scurvy-like symptoms and died. Svirbli and Szent-Györgyi decided hexuronic acid, renamed ascorbic acid to reflect its anti-scurvy properties, was indeed the long-sought vitamin C. The term's etymology is from the Latin a, meaning away or off from, while scorbic is from medieval Latin scorbuticus, pertaining to scurvy.
In 1933, Szent-Györgyi set about to find additional natural source of ascorbic acid for further study. At the same time, Walter Norman Howard chemically identified the vitamin C as L-hexuronic acid, proving this by synthesis in 1933. Partly for the discovery, Szent-Györgyi was awarded the 1937 Nobel Prize in Medicine, and Howard shared that year's Nobel Prize in Chemistry. In this correction, it is worth mentioning that by the spring of 1932, King's laboratory had proven that hexuronic acid is anti-scorbutic factor, but published the result without giving Szent-Györgyi credit for it. This led to a bitter dispute over price.
Another information is noteworthy. Although orange juice and lemon juice have high levels of ascorbic acid, they contain sugars that make purification extremely difficult. Szent-Györgyi solved the problem by making imaginative issue of the local specialty paprika, capsicum. Szeged is the paprika capital of the world, where matching salt and paprika shakers are found on every restaurant table. One night, Szent-Györgyi recalled his wife served him fresh red paprika for supper. As he wrote his autobiography, I did not feel like eating it, so I thought of a way out. Suddenly it occurred to me that this is the one plant I had never tasted. I took it to the laboratory, and by about midnight I knew that it was a treasure chest full of vitamin C.
After its discovery, a demand for pure AA triggered the development of industrial production process in the early 1930s. Between 1933 and 1934, Haworth and fellow British chemist Edmund Hits had managed the chemical synthesis of AA. During the same period, the Polish chemist traders Richtstrain, along with A. Gartner independently developed a method for the large-scale synthesis of AA, making it the first vitamin to be artificially produced. The latter process made possible the cheap mass production of semi-synthetic AA, which was quickly marketed. Haworth was awarded the 1937 Nobel Prize in Chemistry, in part for this work. But the Richtstrain-Gassner process, a combined chemical and bacterial fermentation sequence still used today to produce vitamin C, retained Richtstrain's name. In 1934, Hoffmann-La became the first pharmaceutical company to mass produce and market synthetic vitamin C under the brand name Redoxon. The Richtstrain-Gassner process is outlined below.